Well, good afternoon, everyone. Really lovely to see you, and welcome to the STEMPOINT East STEM Inspiration Week. We have today Natalia Javicic with us. She's from Cranfield University and she's a research engineer, and I'm really looking forward to hearing your talk, Natalia. So I'll hand straight over to you.
Okay. Hello. Thank you very much for attending my session. It's quite strange to talk to your own computer, but I hope you are all there. So before I will jump onto my current role and my research topic, I thought it would be good to tell you a little bit about myself. So I am from Poland. I grew up in a small city over there. I attended primary and secondary school there, and I graduated from the science-oriented class there. After that, I chose to go to the technical university. I graduated from Wrocław University of Technology. I have a master in science in biotechnology with a majoring in environmental biotechnology. That gave me a good background in chemistry, math, and biology. Throughout my studies, I decided to broaden my knowledge and learn some new skills. So I joined as a trainee at Polish Academy of Sciences in a laboratory of medical microbiology, where I gained experience in some essential lab techniques. And after I graduated from Wrocław University of Technology, I gained a European Union Commission grant called Leonardo as a grant for graduates, which allowed me to complete a training at University of Almeria in Spain. So I was there for 3 months in algae group, and that actually I like so much that I decided to do my second master in industrial and agri-food biotechnology, and after that I stayed for 2 years longer as a research assistant, and I worked on a biofuel production from the algae biomass. After that, I decided to move to the UK and pursue my PhD at Cranfield University. So when I first joined Cranfield University School of Water, Energy and Environment, I started in energy and power, and I pursue further biofuel production from the algae. However, the change of circumstances led to the change of my research topic. I changed to environment and agri-food, where I performed a project on an insect-based protein production. When this project was completed, after 1 year, I moved to the Water Science Institute, where I am pursuing my PhD in bioremediation of oil-rich wastewater. And I told you all of that because I believe there is a kind of key message in this. So there might be more steps at your journey, but in my journey, there were at least 4 steps that they were then repeated. So I really believe that this is very important to listen to the advice of others, because when I first consider my future and my future career, I was not really into STEM subjects, and it was only the advice of my teachers and my family that I chose science-oriented class. After that, taking each of the opportunities is really important, and you should never shy of the opportunities. You should never think that you are not good enough or you are not prepared enough to do things. You should gain experience wherever possible, and you should always follow your instincts, because you are not always going to be completely sure on what you should do next. But if you trust your instincts, it will probably lead you to the right path. And then finally enjoy. And that takes us to my research topic. I believe you might have heard about the fatbergs. So the fatbergs are congealed fat, oil, and greases with unflushable items that block a sewer and networks. And just 3 meters below our busy streets, fatbergs are constantly forming. There is at least 10 large fatbergs at the moment in London, with hundreds of them across the country. And I can bet there is at least one in your own city forming right now. So I decided to use this video because I really believe this is actually summarized whatever you need to know you need to know about the fatbergs. So this is the kind of increasing problem in the water sector at the moment. There is no one good treatment for that. The cause of it are people pouring the fog down the drain, food service establishment not maintaining the grease interceptors or grease traps properly. It's a problem that it's unseen because it's hidden, it's below our streets, so we don't really realize how big is that. It's not new, it's just not known to the public so well. The removal is really difficult. It involves people going into the sewers, digging things up. This is the suit that they need to wear when they go there, and they are getting rid of that. Once it's brought up to the surface, it goes to the landfill, so there's not really much done with it. And it's just an issue that we are all causing, and probably we can all stop if we really change the habits that we have. It's quite simple, just if we want to. So that was a kind of knowledge or summary that it would be beneficial for you to have to understand further on my project. So my project aim is to understand how fatbergs form in the sewers and how we can use biotechnology to combat them. So first of all, it's really crucial to understand how do they form. It might seem quite simple because people see them just a solidification of fat because the temperature drops in the sewers. So I can compare it, for example, to melted butter. And when you heat it up, and then after that process is completed and temperature drops, your butter goes back to the solid form again. Or for example, olive oil, when the temperature drops, you can see the small precipitates there. So this is how it's seen at the moment. However, the matrix of the wastewater, the composition of the wastewater is quite complex. You have the proteins, carbohydrates, lipids, you have inorganic and organic compounds, and all of this can actually contribute to the deposits formation. There's really limited knowledge there, and it's really crucial because you need to understand your problem first to be able to treat it. So the second phase of my project is to use the biotechnology, to use microbes or enzymes to inhibit a formation of the fog, which means just preventing formation of fog in the sewer lines, fatbergs, or degradation. So you will have already deposit there, and then you will just try to use biology to degrade it much more efficiently. So basically, since the water companies has a limited ability to address the root cause of the problem, which is the release of fat, oil, and greases down the drain, the reactive approach is the most commonly applied, which means the mechanical maintenance of the sewers. As I mentioned, people go in, people dig it out, really hard work, or if the sewers are not big enough, then there is a jetting. Jetting is you use the water under very high pressure to remove that. But recently the bioaddition is emerging as an alternative, promising method to those measures. However, we need to still understand how to do that. So we know that the microbes that we already have in the sewers, they can be effective in degrading fat, oil, and greases, but they do it very slowly. So the trick is to give them something what can enhance their ability, kind of energy drink, which will boost their ability to do that. Another option is bioaugmentation. So you can bring the bacteria that they are already very effective in degrading fat into the sewers. They will live there, they will thrive there, they will overtake the environment, and they will degrade the fat very efficiently. Or you can use an enzyme. Enzymes are the compounds released by the microbes, and they are already used for them to degrade fats. If you use the pure enzyme instead of microorganism, you can increase the concentration of it, availability of that, and that would increase the efficiency of your treatment. It's also important for you to understand that this is quite a complex problem, and it has a social, economic, and environmental factors. So basically, we have at least three stakeholders, which is public, us, food service establishment, and water companies. So the public and food service establishments are the quite reason for the problem, because we are causing it, we are releasing it. Water companies need to deal with that. They don't really have a choice. But it cost them a lot of money, because it was estimated that last year the cost of it was around 100 million pounds just to get rid of the stuff from the sewers, not including repairs if the pipe bursts or properties flooding. We can fight through the public awareness and education campaigns, so just informing people what to do, what not to do, legislations, and also, as I mentioned, mechanical and biological maintenance of the sewer. If we fail with that, we will have the properties flooding, infrastructure damage, and that will cause the health and environmental hazards. So the most effective is always a prevention, so which means source control. 93% of the Fatberg's masks are the wet wipes. Some of the wet wipes are said to be flushable, but they are not. If you are using those products, you should look for those designed to flush. Recently, the teenager called Emma Greenwood came up with the idea that we could actually put on the packaging of our wet wipes what kind of damage we can do to our sewer networks if we do not dispose them correctly. Furthermore, 75% of the fog in sewers comes from the domestic sources. So now it's October, which is October, is a one month long campaign that challenge people to change their behavior, to avoid doing things that at the end will abuse the sewer system. So not throwing things that shouldn't be there, not pouring your oil down the drain. There has also the communication regarding Fatbergs in media, which is quite widely covered. We had the Fatberg autopsy, which was a documentary about the secrets of the sewers. Fatberg Museum of London exhibition, competition, photo competition. We have also musical, cartoons, and Fatberg comics. And all of that actually help us and also help water companies to spread the news and increase the people understanding of what the Fatbergs are and how do they form. And I was really lucky to take part in investigation of the samples that they were provided by about Fatberg autopsy and Museum of London, and that analyzing them, increasing the knowledge regarding the samples, and also helping them to shape the display and the program. So I believe the role as a researcher is to investigate and also to communicate, but not only to communicate to your colleagues from the same university or the research area. We should communicate back to the public. Most of the projects are actually funded by the public money, so this is also very important to give back, to show people where the money is going to. And it also increases your communication skills and interpersonal skills, which are very important in your roles. So I was lucky enough to present at Soapbox and New Scientist Live and Oxford Science Festival. I was absolutely petrified and anxious about it, but I really believe it was worth it. Finally, what I want to tell you is that your interpersonal skills are as important as your technical skills. You won't have all of those skills just at the beginning of your journey. And all of them you can actively use in your STEM-related roles. You need problem-solving skills, curiosity, effective communication, ability to clarify and paraphrase. And as I said, you don't really need to have the full set of skills. It's enough you have some of them. The rest you just develop and improve as you go. And a piece of advice is that, first of all, STEM related roles are really, really creative. They need both your hard and soft skills. And then you should never shy away from the opportunities you have. The knowledge and the skills you gather are transferable, so you can transfer them in each and every role you do. The key to success is to have an open mind and be flexible. You should use your adversity as an opportunity, so you shouldn't see it as your failure. You should look at it, you should think about it and think what you can do differently next time. And of course, you should give everything you do your best shot, but you also need to remember that sometimes good enough is good enough. It took me quite a long time to understand that just improving things endlessly is just not going to improve the quality. You're just going to waste a little bit more time. And yeah, your career in STEM can be creative, and it's rewarding for both men and women. Yeah, thank you very much.
Thank you, Natalia. That was really interesting to hear about the work that you're doing. And also think it's actually such an important message, isn't it, about how we live now in such a sort of commercial world, and everything's available and very, very ready. You know, I've got a young son, and I know exactly what you're saying about sort of the wipes and things. And there's so much more education now this time around with my second son about, you know, the recycling and the damage it's doing as well. So that's something that we wouldn't have known about even 5 years ago. So I think really, really important. I know that I'm sure that some of the schools have got some questions, so please do use the chat. Vanessa's put a message on there already. If you've got any questions for Natalia or any thoughts, please put them on there, because we have got some time to have a discussion of those. And while maybe the teachers are speaking to the students, just a quick question from me really. You mentioned that for the sort of work that you're doing, the STEM work, that you need some of the soft skills. Can you say a little bit about that and what you mean by the soft skills?
So I will just go back to this slide. So we often forget that actually in STEM is creative. You need also soft skills. You need to know how to communicate with people. You might have a knowledge, you might have ability to you know, I mean, like role related knowledge, you know how to calculate things, you know how to design things, but if you are not able to communicate them to your colleagues, that they might not you know, have your technical knowledge, to your managers, or even to people, your customers, you are failing at your task. You need to try to use the words that they can understand what you really, you know, want to tell them. You also need to be creative, because if you want to find a solution for old problem, you don't always have to go in the same exact solution you had and, for example, worked or maybe did not work. You can come up with a more creative things.
Yeah, no, thank you. I think what's coming through and not just your talk, but actually all the STEM talks that we're hearing this week is about communication skills and creativity. And of course, the science subjects at A-level GCSE, of course, they're important and they're necessary, and you have to have that interest in science, don't you? But actually, these soft skills that you're talking about around communication are so vital. Because you have to communicate what you're researching. Otherwise, you know, what's the point of doing it? So there are two questions actually for you, Natalia. One is around how long will it take to clean up all the fatbergs?
Oh, it depends on the size, but in 2017 they found one of the biggest fatbergs in the London sewers, and it took them 13 weeks just to get rid of the stuff, working weekends and overtime. So it takes a lot of time. It just depends of the size, but it takes quite a long time.
And the thing is, you know, as you've said already, things have to go somewhere, don't they?
Yes.
They don't just disappear because it's gone in the bin or down the toilet.
Yeah.
They still have to get processed and yeah, got rid of really. So yeah, interesting concept to think about. And how easy did you find the international opportunities in STEM?
How easy you find? Okay, so it was not so difficult for me to find, for example, my to go to Spain. So it's just what I really believe, the opportunities are always there and they are not really hidden. It's just sometimes we do not believe that we are ready for them. Sometimes we make a mistake and we think, oh yeah, our profile does not fit the description. I think you should still try. You should just go, on the website and you look, for example, if you look for a PhD, you go to find PhD and you have a list of different opportunities there. You will not always know exactly what you're going to do. It's just, it's just a journey. You just learn as you go. It's just, for you to have a will to look for something. And I think really it's really rewarding when you have an opportunity to study abroad or to go to the conferences, and it's really rewarding career.
It's amazing, isn't it? Yeah, working with different people
yeah,
from all around the world, and must be fascinating.
yeah. The one thing I would like to emphasize, which I think is really important, is that the technical skills, our knowledge and our, I don't know, the math, chemistry and physics, we don't really have to be such a champions in those things just to be able to pursue our career. Many of the things I learned I never used, and then I learned other things that I really use every day. So it's more about gaining your experience. So you just don't have to be very, very good, super efficient in, in STEM subjects, just to be able to pursue your career further, because you will find out that you actually, you have other skills that they can cover up.
No, that's good to hear, isn't it? And it's something that, we often worry about, that young people can drop out of STEM subjects because they're not going to get the highest grades. But actually, it's really reassuring to hear scientists like yourself talking about that, and to say, of course, you have to work hard, because STEM subjects they're not easy. The subjects like mathematics, physics, chemistry, they need study, of course. But actually, you don't need to necessarily get everything correct and be the best of everything, because you just need to do the best that you can do. And that's really coming through from what you're saying. There are two really interesting questions about fatbergs in the chat, actually. We've got one that says, how are they made in the first place, and how do enzymes break them down?
Okay, so how they are made in the first place? Oh, I can talk a very long time about it, because it's quite actually a subject of my work, and this is really exciting that we actually are now discovering how do they form. But basically, you have so when you think about the wastewater, you think about it as a lot of different elements in it. All of them can actually interact with each other. So our understanding is that once oil get into the water, it get degraded. So the oil is basically built up of the smaller compounds, and those small compounds get into the water, and then they start to react with, for example, sugars in it, and then you start to get the precipitates. So you think you have a clear water, kind of clear water, and then you start to have some precipitates, and then other things adhere to it, and it's like a snowball. It just builds up and builds up and builds up, and then we add wet wipes, which are actually creating more of the surface, and it's just getting bigger and bigger and bigger. And the second one was how the enzymes can degrade it.
Yeah, how do they break them down? Yeah.
Yes, how do they break them down? So basically, when bacteria use the enzymes to, degrade the compounds. So again, you think about the lipid as a long chain built up of the different compounds, and for the bacteria to be able to take them in and use them, they need to cut them. So the enzymes are kind of scissors that they're going to cut it and allow them to degrade it and eat it up. So I would explain the enzymes, how enzymes work in this way.
Okay, and I'm sure students have learned, at least a little bit about that already, depending on what year groups they're in. But I actually didn't know anything about fatbergs, really. So I've definitely learned about that, and how the impact they have really on the environment as well, and people's lives. Are there any other questions from the schools? Please don't hesitate to put different things on the chat as well.
Okay. I have Fatberg quiz, but I think I'm not sure about how long we have left, and
do you know how long it might take to do the quiz?
It's 12 questions.
So we're aiming to finish by sort of 12:15. Vanessa, correct me if I'm wrong here. I know you are there as well. So hopefully we should have some time. Is it something that you have to share on the screen?
I have it as a part of the presentation.
Okay, well, shall we go ahead with that? And schools, if you do need to go, I know it's lunchtime and all sorts of things at the moment, then do feel free, or probably the end of lunchtime actually. But if you can stay and do the questions, that will be fantastic.
Yeah.
So do you want them to write the answers down and then you'll go through them?
Yes. So I have the answers at the end. So if they
fantastic. So yeah, do write them down, maybe work through as classes or groups. If you do need to go, Vanessa has put the evaluation link on the chat. So teachers, if you could do that for us, we'd really appreciate it. The session is being recorded as well, as you were told before, and we will share the recordings with you as well after the session. Okay. But if you can stay and do the quiz, that's great, and we'll go through the answers at the end.
Okay. Yeah, just let me know when it's time to switch to another slide. Yeah. What also amazed me is the amount of, on the media coverage regarding the fatbergs. People find it fascinating. They just find it fascinating. It's disgusting, but it's also fascinating them because it's the way how we live. Is us causing that. It's our throwaway society that we think we can just dispose whatever we have without the consequences. And when it's gone, it's gone. But it is actually a huge problem.
Can I just jump in? Can I just jump in and just say to the teachers, if you would like to do the quiz, could you just do a reaction, like a little thumbs up, so we know to go ahead with it, please?
We've got one school, fantastic.
Oh, brilliant.
And Louise has said yes, so that's 2 at least, so that's great. So you should hopefully be able to see questions 4, 5 and 6 now.
Yeah. Should I move on? Should I move to the next slide?
Yeah, we can do. If you need to go back, just shout, teachers, but hopefully that was enough time. Could you just quickly go back? Sorry, Natalia, can you go back to question 6 very quickly? Just for one of the schools. Thank you. Louise, let us know when it's okay to move on. Brilliant. Thank you. Next one, please, Natalia.
Okay. There's one more. Should I move on?
Yeah, is that okay, teachers? Shout in the chat if you want another question, but let's look at the last 3 questions then, Natalia. I think they're happy for you to move on. You've given the answer to one of these already. I hope they've all had their lunch, because the last question, yeah, it's not very appetizing.
No. No. The whole topic probably is not.
So we've got one school at the moment who've said they're done.
Yeah.
Are we happy to look at the answers? Yeah, there's another one. So
Yeah.
I think we can look at the answers. So what was the cost actually? Because I didn't write down the letters. The cost to the British economy, the UK economy, to clear up the fatbergs.
£100 million. 100 million pounds, and this is just, you know, for them to clean it, but you have associated costs. You have to go and inspect, you have to deal with the, you know, if you have your pipe burst, you need to deal with that, you need to repair those things, you need to, you know, not counting the reputation damage, you know, you overflow somebody's property, or it can get even worse. It can get to the groundwater, so the raw sewage spillages. Yeah.
So we've got 9 or 10 out of 10 for the schools, and I actually thought it'd be 10 to 30 million. So I was sort of erring on the side of caution. But yeah, 100 million plus associated costs. That's quite a lot, isn't it? So
yes, it's a huge amount. Yeah. And there is no solution for the problem. That's the reason we all need to work together. We need to educate people. Water companies, they need to, you know, as well, you know, tell people, maybe sending information, because most of the time it's not that people, they do it on purpose. Most of the time you just don't know, or you are misled. For example, the wipes, some of them, they have that, you know, the sign that you can flush them, but they just don't disintegrate. The only thing is that they will go down, they will flush, so they will not cure, but they will not disintegrate.
And that's such an important point, Natalia. Well, it was so informative, and I think, you know, such a worthwhile message. And in a world where I think, you know, we and young people are really, really interested and really inspired by sort of sustainability and recycling and trying to save really the you know, climate change agenda, all sorts of things. So I think your talk was really, you know, really timely for that and really interesting, and I'm sure the schools enjoyed it as well. Thank you very much. I've learned so much from you today. Thank you, and thank you to the schools as well. Please don't forget to do the evaluations for us, and we will send you the recording soon. And thank you, Natalia. Really appreciate your time.
Thank you very much.
Thank you, everybody. Thank you, Natalia.
Bye.